Good morning to one and all present here. I am going to present my topic heat transfer. Introduce about myself. I am Dr. P.K. Manikandapirapu. I did my engineering in Webcoastline Engineering College 2005. I did my post graduation in PSG College of Technology Coimbatore in 2007. After my graduation of PhD degree in 2018 in Visvesvaraya Technological University, Karnataka, Belgaum, I did. I am having 10 years teaching experience in my career. Previously, I have worked in Dayananda Sagar College of Engineering, Bangalore, and NIT Calicut, as well as I'm in Adiyaman College of Engineering for past 3 years, and finally I in VSB Engineering College Karur 1 year as associate professor, as well as finally I have worked as an associate professor in PSN College of Engineering and Technology, Tirunelveli from past 1 years. This is my introduction of myself. Now I am going to discuss about the subject of heat transfer. I am going to give the presentation of heat transfer subject. In this topic, first I have to start with the introduction and terminology of heat transfer. What are the introductions available and terminology, what are the important terminologies that we will discuss. First term, heat. What is the meaning of heat? Heat is the form of energy that is transferred across the boundary by the virtue of temperature difference. Now the term is heat transfer. Heat transfer is a science which deals with, determines the rate of thermal energy. Now I am going to discuss about the flows, like what is the heat flow, what is the meaning of current flow, what is the meaning of fluid flow, and what is the meaning of rotational flow. Temperature difference, anything, when you are going to the subject, anything is a difference. So anything, temperature difference, potential difference, pressure difference, density difference. If any difference, mainly the temperature difference is the driving force of heat flow. Same thing in the current flow or current. Now when using the electricity and using the computer, laptops or any applications, you are using our mobiles, anything, current flow is there only when able to use the systems. So main thing is potential difference. The potential difference is that is a driving force of current flow. Second one, third one is the pressure difference. Pressure difference is the driving force of fluid flow. Pressure difference is the driving force of fluid flow. And the final one is density difference, is the driving force of rotational flow. It creates, first one is temperature difference, is the driving force of heat flow. And potential difference is the driving force of current flow. And pressure difference is making the driving force of fluid flow. And density difference is the driving force of rotational flow. This is we have seen these pictures. The more I have to explain about the modes of heat transfer. What is the modes of heat transfer? It means 3 modes of heat transfer available in HMT. One is conduction, second one is convection, and third one is radiations. This is the 3 modes of heat transfer. That is example in a stove. We are using the jug. We are applying the milk or water, anything. When your fuels apply and the ignition of the fuels by using LPG, then the heat transfer to the water, and the first conduction by using the mug or jar, whatever using our stationary items or anything as using as our jugs and more, that energy transfer by using conduction. That energy is transferred to the water by the mode of convection, and the energy transfer pick up by using the third mode is radiations. So we are in like example of using our water in a pot, and we are handle using in their mode conduction. Convection is in water molecules, and radiation is energy transfer by air molecules. How energy transfer takes place is so in our pictures. It is an obvious example is warming of earth by suns. It's one of the examples of thermal radiation from the human body. It's a normally rotation of air as well as earth warming. We are morning itself hot and evening cool. With the time with respect to 6 o'clock itself, sun starts sun shining, and because of the due to the heat, we get the warm of earth. All the birds wake up and do their work, and human also we have to do our work level. It is morning itself, heat transfer takes place in each and every mode. When you are able to sleep and wake up the morning and do our work and take sleep, immediately we are taking breath of air. That is one of the important heat transfer. Internal system and external system. The both system we are taking breath also. We got sweating, means in the room itself we got by using air conditioning applications we can use. Because increasing our the mood, using the heat transfer, important furnace cooling in induction furnace. Each mode of furnace also available in heat transfer. We can go through the PPTs. First mode, conduction. Conduction is defined as the transfer of energy. Conduction is defined as transfer of energy from more energetic particles, high energetic particles of substance, to adjacent, less energetic one, high energy to less energy, as a result of the interaction between particles. The interaction between particles is an important mode of the heat transfer in conductions. Conduction theory is based on the Fourier's law of conduction. Fourier's law only is made up of the theory of heat transfer in conduction. As per the term only we are studying the conduction of in the subjects. The transfer of energy from more energetic particular substance to adjacent less energetic one as a result of interaction between particles. That is the meaning of conduction. That is Fourier. What is the Fourier law? Q equal to minus Ka delta T by del X. What is the meaning of delta T? Delta T is temperature difference. Del X is the length with respect to the X directions. What is the meaning of A? A is the area heat transfer area of the material. K equal to thermal conductivity of the material. Q equal to heat transfer. Q equal to minus Ka delta T by del X. For the examples, when frying vegetables in a pan, heat transfer takes place from a flame to the pan and then to vegetables, adding the energy in the mode of conduction. Now that is the example we have seen in already the pan is already heat supplied, more amount of energy. We are using this pan handle by direct conduct. Conduction means direct conduct of the energy. The energy is transferred. Already the two concept is the insulator or conductor. Conduction more energy by using the thermal materials. Various materials available. First example, steels, aluminium, metal, diamond and gold. Each type of material different the value of the thermal conductivity. According with respect to due to the thermal conductivity value, that unit is watt per meter Kelvin. With respect to this mode, only heat transfer takes place in this conduction. Thermal conductivity value is less as in insulator materials. So thermal conductivity value compared in the steel is higher value compared to asbestos, or insulator or wood materials. So thermal energy is transferred from the material to one material to another by using the direct contact. Only transfer takes place. Now the second mode of heat transfer. Convection is the mode of heat transfer between a solid surface and adjacent fluid, that is in fluid motions. Convection is the defined of mode of heat transfer between a solid surface as any material and adjacent fluid flow path takes place. So adjacent fluid, that is also fluid motions. When energy transfer in hot fluid or cold fluid, anything flow passes through the channel or circular closed pipes or through channels. In like fluid trans, like snake is will fall in this water, like any solid surface flow over a surface or open channel or closed channel in a pipe or open. Anything adjacent fluid that is in motion. Its involvement of the fluid flow is that means the combined effect of conduction and fluid motion. Example of heating of milk in a pan. Now we have to discuss about the convection heat transfer is based on. What is the mode of heat transfer? Is based on the theory. The great inventionist as well as great scientist Newton. Newton's made up of the rule in the heat transfer, Newton's law of cooling, Q equal to H A delta T. Delta T is temperature difference. Anything heat transfer takes place means difference in the temperature only, no other way. Only the temperature difference. Temperature difference based on the law. And A is heat transfer area, and H equals heat transfer coefficient, Q equal to HA delta T. In this picture we have shown in examples of convections, the boiling water or heat or temperature in a room or oceans. Here anything in the mode of like tumbler, water is there. We are taking high amount of temperature involved. We are boiling water in a pot or in a tumbler. We are using water and adding the temperature of energy by using LPG and supplying the full fuel amount. In even 10 minutes, its water will be boiling. That normal cold water will be boiling with high amount of energy. It automatically vapor will pass through over the surface. So this is one of the examples of convections because fluid motions is available. In these two types of convections, one is forced convection and free convections. What is the meaning forced? What is the meaning of free? The fluid is forced to flow over a surface. Fluid is forced to flow over a surface by external. Fluid is forced to flow over a surface by external means. Forced convection. Like in example is a fan, blower, compressor, internal compressor, external compressors, more industrial compressors, blowers used for these applications. Examples water heaters or geysers for instant heating of water, and using a fan on hot summer day. Now we are taking milk in outside tea shops. We are going and take the tea shop. We are giving the amount and we are paying the amount and we get the tea. Get the tea. We are using tumbler. There is more amount of heat from the oven. So he is transferring the heat by hand as an external device. That is one of the example of forced convection. Increasing the heat transfer rate by using external medium. In this mode, we can see this forced convection as an example. Now, we are going to discuss about free convections. Free convection means fluid motions is caused by buoyancy. Fluid motion is caused by buoyancy force that are induced by density difference. That are induced by density difference due to variations of temperature in the fluids. The fluid motion is caused by buoyancy force that are induced by density difference due to variation of temperature in the fluid. Now already we have seen in the buoyancy force that are induced by density difference. What is the meaning of density difference? We are taking cold water, just amount of adding energy. Just we are taking small water pot and adding the water and applying the heat. Heat added, getting amount and the amount of energy is absorbed by the cold water. It will becomes hot. So hot water get less density. It more will become it will be lesser. So it will become upward. More amount of cold water density will be more. It will become downwards. So fluid motion is caused by buoyancy force only that are induced by density difference due to variations of temperature in the fluid. Like see, the cold water is there, here warm water is there, heat transfer, egg, we are boiling the amount of heat, the circulation will start with the water, the energy transfer to egg and as well as water also. Here the circulation starts from warm air, it will get more density, so it will become upward. Cold water will come downwards. So circulation, because of the circulation only energy transfer takes place in free convection mode. Now third mode of heat transfer. First we have seen conduction and the second mode is convection and third mode. Third mode of heat transfer is radiations. Energy emitted by a matter in the form of electromagnetic waves as a result of, what is the result? Changes in the electronic configurations of atoms and molecules. Energy emitted by a matter in the form of electromagnetic waves as a result of changes in the electronic configurations of atoms or molecules. That is the definition of radiations. Now we are going to discuss about the radiation of heat transfer is based on the Stefan-Boltzmann's law. Already we have discussed within conduction, Fourier's law. Conduction's which law? Newton's cooling law. And third one is radiation heat transfer is based on the law is Stefan-Boltzmann's law. So define radiation: energy emitted by a matter in the form of electromagnetic waves as a result of changes in the electronic configurations of atoms or molecules. Now this mode of heat transfer in Stefan-Boltzmann's law is Q equal to sigma A del over T whole power 4. Sigma is 5.67 into 10 to the power minus 8 watt per meter square Kelvin per 4. Here temperature difference in the form of fourth power will be updated. So Q equal to sigma A delta T whole power 4. Delta T is temperature difference. Area equal to A is heat transfer area. Sigma is Stefan-Boltzmann constant. And the value is 5.67 into 10 power minus 8 watt per meter square Kelvin per 4. Now we are going to discuss about the radiations. The examples of radiation is a microwave. The substances are heated directly without any heating medium. In the microwave, the substances are heated directly without any heating medium. The heating of the earth by the sun is an example of transfer of energy. The heating of the earth by the sun is an example of transfer of energy by radiations. In microwave, another one important transfer is microwave. The substances are heated directly without any heating medium. Microwave transfer energy also is used for the mode of heat transfer. This is one of the two examples in radiations. Application of heat transfer. Heat transfer is used in engineering systems. as human life also. Heat transfer is used in every engineering system. What are the engineering system available means internal combustion engines, external combustion engines, IC engines for two-wheelers and four-wheelers. Same as example is marine vehicles, marine engines, or in seas, ships, and sea. We have see the very lot of number of boats are used in the based on the heat transfer systems, as well as gas turbine engines, external gas turbine engines like aircrafts and barrier aircrafts and military aircraft vehicles. Everything is based on the external engineering systems is used in heat transfers. And human life also, when you are able to breathe, inside the molecules transfer the energy, blood circulations, and the pump as a heart is functioning, is pumping the blood energy from circulation from head to leg, energy transfer from lower level to higher level to lower level, the transfer of energy, and as well as sweating and skin, that also heat transfer takes place. Constantly heat body is constantly rejecting the heat to the surrounding. Energy transfer means temperature difference. Main concept is temperature difference. Higher energy, lower energy. Transfer takes place in the example is engineering system as a material as well as human body. Not only human body, all animals, bats, all other animals and humans also rejecting to surrounding. Examples of heat transfer is used. And design of many other devices like car, radiators, solar collectors, various kinds of power plants and spacecrafts is used in the based on the design of heat transfer and theory. It will be used for our applications. Lot of researchers is working on this in the field. What are the field means, like many fields, solar collector, solar panel, and systems, industrial system and computers, the air cooling device by using in small vehicle also we can using the more small type of miniaturization of fans using nanotechnologies. We can see the every application, we can see the applications of heat transfers. In these various types of applications, first we have discussed about the fins. Fins means in the study of heat transfers, fins are surfaces that are extended from an object, extension of the object, some extending the material. It is the ability to object to useful to increasing the rate of heat transfer, to or from the environment by increasing on convection modes of heat transfers. Fins are widely used in various thermal systems such as heat exchangers, refrigeration systems, electronic cooling devices, and many more. The primary purpose of fins used to increasing the surface area of heat transfer and device. Thereby improving the heat transfer, also increasing the efficiency in fins, increasing the heat transfer sections, adding the area to increasing the heat transfer by the mode of convection mode. It is used in air cooled heat exchangers, refrigeration systems, electronic cooling devices, and many more. Adding the efficiency and the effectiveness in the fins. Various types of fins available, we can see. The fins are slender extensions or protrude mode attached to the original surface, where protruding the mode of heat transfer in rectangular size or circular shape size fins are you can use. The shape and size of the fins can vary significantly depending on the applications and nature of the heat transfer problems. The most commonly used fin geometries are rectangular, triangular, circular type of fins. Fin efficiency also varied. We can using the heat transfer data book various type of geometry. We can see the effectiveness and efficiency formula. We can able to calculate the theory of how energy transfer takes place in fins. Fins can be made of various metals such as metals, plastics, ceramics, and composites depending on the operating conditions and desired properties. The critical radius of insulations. The critical radius, next concept is critical radius of insulations. Already we have seen what are the modes of heat transfer: conduction, convection, radiations, and what is the application of heat transfer. What are these modes based on Fourier's laws, Newton's law of cooling, and Stevens-Boltzmann's law we have discussed, and we have discussed about the fins. In this fins also we have seen the triangular, rectangular fins and their efficiency is in formula. According the formula we can calculate the various type of materials are used and their applications we have seen. Now we are going to discuss about critical radius of insulations. What is the meaning of critical radius of insulations? The critical radius of insulation is a counter-inducive concept within the study of heat transfer. The theory states that adding insulation to a cylindrical or spherical object first will increase the rate of heat loss rather than decrease it. If the radius thickness adding the insulation is a critical value. The critical radius of insulation is the thickness of insulations at which the rate of heat transfer through the body is maximum. Now, adding the material, it automatically increases the heat transfer area, but certain point, that is the point itself, critical radius. Then after adding the material, is not upon like that. It automatically decreasing the heat transfer. What is the point? That is the point itself, critical radius of insulation. That point itself at which the rate of heat transfer to the body is maximum. The heat transfer increases with increasing thickness of insulation up to critical radius of insulations. If we are increasing the thickness more than that value of critical thickness, heat transfer start to decrease. The value of critical thickness depends on thermal conductivity of the material and convective heat transfer coefficient at the surrounding of insulations, and the three values are depends on only conductivity and heat transfer coefficient of the materials. It depends on that. The insulation used for electrical conductors. Example, we are going to see this the topic critical radius of insulations. Now we are going to see that the electrical insulator is one of the good insulator, is a good conductor. The insulations used for electrical conductors are good insulators for electricity and good conductor of heat. Now we are going to discuss about the formula critical radius of insulations, or CR. Or CR means critical. CR means critical insulations of radius of critical insulations equals K by H. K means thermal conductivity of the material. H means heat transfer coefficient. Heat transfer K by H. Thermal conductivity divided by heat transfer of the material. As we increasing the layer of insulations on cylindrical or spherical surface, the area exposed to the surrounding also increases. We are increasing the layer of insulation on cylindrical and spherical. The area exposing to the surrounding also increases. The increased surface area increases. The convective heat transfer also increases up to critical radius. The conductive resistance of insulation is dominated by rising the convective heat transfers. Therefore, up to the critical radius of insulation, the rate of heat transfer is increasing directly, forwardly dominating the heat transfer value is increased. After that, the value will be decreased because exposing the area of surrounding also increases. Because of the reason only, the value will be critical radius value is decreased. Or this is for cylinder, or critical equal to k by 2h. For sphere, or critical is 2k by h. H is heat transfer coefficient, k is thermal conductivity of the materials. They we have explained in the critical radius. Now we are going to discuss about third stage, transient heat conductance. Morning we have discussed about first the topics. What is the mode of heat transfer? Conduction, convection, radiations. Then we will discuss about the theory. Conduction, convection, radiations. Conduction by Fourier's law, convection by Newton's law, and third law is Stephen Boltzmann's law by radiations. Then we have discussed about fins. What is the fins? What is the triangular or rectangular fins? And their circular cross section, and study the effectiveness and efficiency formulas. Now we are going to discuss about transient stage heat conduction. And third we have discussed about critical radius of insulation. Critical radius adding means heat transfer increases, then decreases. That we have discussed about the third topic, critical radius of insulation. Now we are going to discuss about transient stage of heat conductance. Transient conduction refers to a process during which the temperature changes even with respect to each every time, because steady movement and steady movement. With respect to the time is constant means steady. With respect to the time is not constant. With respect to the time is will be vary. Each and every moment energy transfer take place is very different value. We got very different value. That is unsteady. Transient conduction refers to a process during which the temperature changes with the time at any given place within an object. It will be vary means that is called transient stage heat conduction. Non-steady state conduction is another term. It refers to the depends on the temperature on the time with respect to the object. It will vary means that is non-steady state or transient state of heat conductance. In this transient state conductance, we are going to discuss about lumped state system, a lumped state heat analysis of the system, and as well as steady state. Steady state we have not discussed. Only study about and transient states. Transient states, first state, lumped system analysis. What is mean lump? Is total, completely in a particular system. Interior temperature of some body remains essentially uniform at all temperature, all time. That is in the heat transfer process. Now we have already concept heat transfer means mCb delta T. Q equal to Ka delta T by del X. Q equal to Ha delta T. Otherwise another formula, effectiveness Q equal to emissivity and epsilon sigma A delta T equal to 4. Now we are going to discuss about Q equal to mCb delta T. Q equal to m equal to mass of the material, mass of the fluid, Cp specific heat at constant pressure. Delta T is universally everyone know, but the temperature depends only heat transfer takes place, so temperature difference. So Q equal to mCb delta T. Now we are going to discuss about characteristic length L. L equal to V by A. V volume of the body, A heat transfer area, means we got the characteristic length. That length we have to substitute in L. So because here non-dimensional number will vary, will come to the picture. One of the important number is Biot number. In transient stage we have to study the non-dimensional numbers. One of the important number is Biot number. It is used for in lumped system analysis. Biot number is used for lumped system analysis. Biot number equal to HL by K. K equal to thermal conductivity of the material. L equal to length of the area. That is characteristic length. H equal to heat transfer coefficient. This is the number. Biot number is defined as convection at the surface of the body. Convection at the surface of the body divided by conduction within the body. Biot number defined as convection at the surface of the body divided by conduction within the body. We have studied the convection at the surface of the body divided by conduction within the body. Biot number is the ratio of internal resistance to external resistance of heat convection. That Biot number means Biot number is defined as convection at the surface of the body divided by conduction within the body. Heat transfer due to convection divided by heat transfer due to conduction. That is called Biot number. That's all. Now we are going to study about the various numbers. Non-dimensional number is very important aspects in heat transfer. Because every time we are going to we cannot able to conduct the experiments analytically or theoretically, experimentally we have to conduct the experiment. Every time we cannot able to conduct the experiments, but we can't able to conduct the experiments by using experimental practice. Because we need to time, laboraries and time consumptions, amount, every financial, everything is important in the account. Because due to the nature, non-dimensional number introduced in the heat transfer subjects. First non-dimensional number we have studied, already we have studied Biot numbers. Now we are going to study about Fourier numbers. Fourier number is the measure of heat conducted. Fourier number is the measure of heat conducted through the body relative to heat stored. A larger value of Fourier number indicates the faster propagation of heat through a body. So how much amount of heat conducted through the body relatively heat stored, that is mentioned in this Fourier numbers. In real conditions, the heat transfer mostly takes place in transient way only. All the heat transfer is transient heat transfer only in natural phenomena. Here the some examples of transient heat transfers, examples of heating or cooling of engines. Engine study is natural transient state heat transfer. Same thing, heat transfer in building in a day. In every 1 hour itself, temperature distribution is vary with sunshine, with respect to solar plate collector as well as building, everything heat transfer will be vary in every 1 hour, morning to evening. And the same as another example is cooling transfer takes place, and heating in the day to night, cooling transfer takes place, as well as heating in of foods. Heating of metal bars is one of the important transient state heat transfers. Heisler chart is used for in transient stage heat conduction. We can use the HMT data book also. We can see the Heisler chart and study how you compute the progress in transient stage. In transient stage, in 3 modes of heat transfer. One of the things is Biot numbers, and another one is semi-infinite body and infinite medium heat transfer takes place. Also we will discuss. In this, Heisler charts used for in a graphical method to analyze transient heat conduction systems. This method is used to, the Biot number is 0.1 to 100 can use. Heisler chart is different for infinite long plane ball, cylinders and spheres we can use. Now we are going to see the non-dimensional numbers. The first numbers already we have seen Biot numbers. Second number we have discussed Fourier numbers, and third number is Reynolds numbers. Reynolds number not only studied in the heat transfer only, in fluid mechanics also and HMT also, in all gas dynamics also we have seen the Reynolds numbers. In fluid mechanics, the Reynolds number is a non-dimensionless quantity that helps predict the fluid flow patterns in different situations by measuring the ratio between internal force divided by viscous force. This means inertial force is a ratio of inertial force to viscous force. Reynolds number is a dimensionless quantity It helps to useful to predict the fluid flow patterns. So okay, in different situations also. Okay, how we can measuring the ratio of inertial force to viscous force. It's a low Reynolds number. Flow tends to be dominated by laminar flow. Flow tends to be dominated by such like seeds like a seed flow or a small dream in like channel flow, small layer by layer in drop by drop in fluid flow in through pipes also, drop by drop flow. So water like a stream, slow by process we go through the channel like small layer added and through the go to the channel. So we can drop by drop in even close the water in the pipe also, leakage in the water, small one by one drops. If you pass through that one by one water in carried in this small channels in outlet in home in outer channels, this small layer of water is passing through the channels. That is example of viscous flows, and as well as Reynolds number in passed through the in laminar flows. That while at high Reynolds number, flow tends to be turbulence. Laminar flow or turbulent flow, whatever it be, that Reynolds number is important. Predominant force in Reynolds numbers, inertial force or viscous force. High inertial force, high, you got Reynolds number. Viscous forces will be very less Reynolds number. We got laminar flow. High inertial force will get like stream turbulent flow. Turbulent flow like how the waterfalls or boat when you are going in the boat in like engine boat or very fast moving by boat as a sea, like that is turbulent flow natures. Nusselt number. Nusselt number. Now we have discussed Biot number, Froude number, Fourier number, and Reynolds number. Now we are going to discuss about Nusselt number. Nusselt number is defined as a ratio. Is the ratio of convective heat transfer to conductive heat transfer under the same conditions. Already we have seen Biot number equal to Hn by K. Same in solids that Biot number. Here Nusselt number in convection mode. Heat transfer in convection mode. We have an important predominant non-divergent number is Nusselt number. Nusselt number equal to Hn by K. This is defined as the ratio of heat transfer of convection divided by heat conduction and heat conductive heat transfer under the same conditions. Now we are going to see the another number, Grashof number. Now, Grashof number is predominant number in free convections. In forced convections, Nusselt number is used. In free convections, Grashof number is used. Grashof number gives the ratio of buoyancy force to viscous force. Is the ratio of buoyancy force to viscous force. It is used to determine the flow regimes of fluid boundary layers into laminar systems. Actually, flow will be very less number of Reynolds number flow will be less, and Grashof number, this is one of the important number in free convection mode. So it is a very not forced mode. So Reynolds number value will be very less value only will be there. It's important ratio of buoyancy force to viscous force. It is used in laminar system only. Now we are going to discuss about two types of flow, laminar and turbulence. What is laminar flow? What is turbulent flows? In fluid dynamics, laminar flow is characterized by fluid particles flowing in smooth path in layers, with each layer moving smoothly past with adjacent layer with little mixing or not mixing. That is called laminar flow. Because example, in lower velocity, the fluid tends to flow without lateral mixing or adjacent layer, slide past one layer over another like playing cards, one layer to one layer. That is called laminar flow. Now we are going to discuss about turbulent flow. Turbulent flow is a type of flow or gas or liquid is used in this flow in which the fluid undergoes irregular fluctuations. Fluid undergoes irregular fluctuations or mixing in the flow or in contrast laminar flow or in higher than the laminar flow in which fluid numbers moves smooth path or layers. Smooth path or layers. Turbulent flow in the speed of fluid at a point continuously undergoing changes. Continuously undergoing changes in both magnitudes and directions. The turbulent flow is a fluid is very fast manner in a gas or liquid in anything in which the fluid undergoes irregular fluctuations. Typically in open channels, closed channels. Closed channels 500 or 300 or 2000. 2000 only, less than 2000 laminar flow, more than means turbulent flows. In open channels 5 into 10 power 5, less than 5 into 10 power 5 laminar flow, more than about this turbulent flow. Turbulent flow means like in that in western ghats, seesaws, and the flow will be like very fast from higher level altitude to lower level altitude, seesaws, everything that flow will be covered. Like that is the example of stream flow. This is turbulent flow in cycloidal and natures. In this is seen our pictures, laminar flow and turbulent flows. Now that type of flow is viscous flow. Viscous flows occurs when the effects of fluid viscosity is an important parameter, is balanced by those arising the fluid inertias and body forces and pressure gradients. Viscous flow is one of the important type of flow. When those effects of fluid viscosity are balanced by those arising the fluid inertias, body force and pressure gradients. Because since first three type of flows, laminar flows and turbulent flows and viscous flow. And now we are seeing about non-dimensional numbers. First number we have discussed Biot number, then Biot number, Fourier number. Then we have seen Nusselt numbers and Grashof numbers. Now we are going to see the new numbers. Prandtl number is a boundary layer. Who is invented boundary layer means one of the important person is Prandtl. Prandtl only derived the theory of laminar boundary layer theory, turbulent boundary layer theory, thermal boundary layer, fluid boundary layer and fluid thermal boundary layer mixed. Everything is invented by only the great inventionist and scientist Mr. Dr. Prandtl. Dr. Prandtl is invented the theory because of the name. We have had the name Prandtl number. Prandtl number is defined as the ratio of momentum diffusivity to thermal diffusivity. Reynolds number rho v d by mu. Mu is dynamic viscosity. Mu by rho is kinematic viscosity. That term will be covered. Now is the ratio of momentum diffusivity to thermal diffusivity. What is the meaning of diffusivity? The amount of material to diffuse to the material, the amount of energy to diffuse, how much amount of energy to diffuse, that is the important parameter. So K by rho C is diffusivity. Now we are going to discuss about momentum diffusivity to thermal diffusivity. Now we have discussed about thermal diffusivity. Already momentum diffusivity means kinematic viscosity. Kinematic viscosity means mu by rho, that is kinematic viscosity divided by thermal diffusivity. Mu Cp by K. Welcome, Prandtl number. Now we are going to discuss about heat transfer. Another mode is boiling heat transfer. Boiling heat transfer involves changes in a phase. Which are changes in a phase? Actually, three type of phase: liquid phase, gaseous phase, steam phase. Like that phases. Water phase, water, converted into vapor. That will be ice and the solids. So three type of phase: solid, liquid, vapor. Solids, liquids, vapors. Three type of phase. Now we are going to study about boiling heat transfer. The transition of the phase. One to another phase is converted into one layer to another layer. Boiling heat transfer involves changes of phase from liquid to vapor. Changes of phase from liquid state to vapor state. Where there viscosity, density, thermal conductivity, viscosity, density, these are important parameters. Viscosity, density, thermal conductivity and specific heat of the fluid would be used to describe single phase heat transfer in boiling, and additional properties are required. Now we are going to see the heat transfer, the parameters: viscosity, density, thermal conductivity, and the type of material will be there. That is first we have to study the materials. And what are the properties available we have to see in this HMT data book. And what is the thermal conductivity value will be there. What are the value will be in heat transfer coefficient value will be there. First you have to study. Then you have to compute with non-dimensional numbers. What are the various non-dimensional numbers available in our data book, as well as heat transfer, like that we have to study. Then this non-dimensional number study we have studied already: Biot numbers, Froude numbers, Euler number, then Fourier numbers. Then we have studied the heat transfer in these Reynolds numbers, and another two numbers is available. What are the numbers available in heat transfer? Reynolds numbers, Nusselt numbers, Prandtl numbers, Kreshoff numbers. These are the important numbers in non-dimensional numbers. Now we are going to discuss about boiling. Boiling heat transfer involves changes of phase from liquid to vapor. Used to describe single phase heat transfer. In boiling, many additional properties are required. Boiling, we can see what are the types of boiling: pool boiling and flow boiling. Pool boiling and flow boiling, as post boiling or convective boiling is available. In pool boiling, what is the meaning of pool boiling? Bulk liquid is quiescent, while the liquid near the heating surface moves due to the free convection, and mixing is induced by bubble growth and attachment and detachment. Growth, attachment, detachment, bubbles will cover. This is the boiling. What are the types of boiling we have studied in these subjects. During this boiling, heat transfer from a hot surface to a cooler surface by the mode evaporations across liquid vapor interface. Evaporations across liquid vapor interface, and transient stage of convections, and third one is micro convections. First, evaporations from hot surface to cooler surface by evaporations. Second one is liquid vapor interfaces in between happens, and second stage is transient heat conductions, and third one is micro convections generated by nucleations and growth and deposits vapor bubbles. Attachment, detachment, the bubbles will play great mechanisms in heat transfers. In boiling regimes, each value of excess temperature increases. The curve transfers the four different natural regimes. One is natural free convections, and second one is nucleate boiling, and third one is transition boiling and film boiling. It's a four regimes: natural free convection mode, and second one is nucleate boiling stage and transition stage, and fourth one is film boiling. This is the nucleate boiling curve. Here heat flux, here temperature rise. Adding the temperature, first stage is natural convection stage, and second one is nucleate boiling stage, and third one is partial film boiling, and fourth one is film boiling. Adding the heat transfer, how heat transfer will vary with the natural stage, nucleate stage, and partial film boiling and film boiling stage in this shown in figure. Nucleate boiling is a type of boiling that takes place when the surface temperature is hotter than saturated fluid temperature by a certain amount, where the heat flux is below the critical heat flux means nucleate boiling. is a type of boiling that takes place when the heat temperature, surface temperature is hotter than the saturated line by a certain amount, but where the heat flux is below the critical flux means nucleate boiling. Now film boiling. Film boiling is the form of changes of phase heat transfer, which is characterized by a solid body, and transferring the heat to surrounding liquid through intermediate vapor film. The film boiling is a form of change of phase heat transfer. Which is characterized by a solid body transferring heat to surrounding liquid through a intermediate vapor film. The vapor films form a continuous vapor films relatively regular blanket and over the solid surface. That is the film boiling. Now the two-phase region. Actually phases, single phase flow, multi-phase. More than one phase means multi-phase flow. The transition region is liquid and vapor region. More than one phase is involved in the tube. Exhibits a different flow boiling regimes depending on the relative amounts of liquid phases. Typically flow regimes like liquid single phase flow and bubbly flow and slug flow and annular flow and mist flow and vapor single phase flow. These are the three various regimes of flow. The liquid single phase flow and bubbly flow and slug flow and annular and mist and vapor single flow, and these are the regions of the flow in flow boiling. When you transferring the heat of the energy absorbed through the water in the flow through the channel, the energy transfer takes place in the boiling mode. It's happened in the two flow boiling sections. Now we are going to study the condensation. Already we have discussed various modes of heat transfers: conduction mode, convection mode, radiation modes. What are the governing equations? Fourier's law of conduction, Newton's law of cooling, and Stephen Boltzmann's law of radiations. We have discussed. Then we have discussed about fins. External surface adding the extended surface, adding the heat transfer by using fins. Rectangular sections, diagonal sections are used. And we are adding the critical radius of insulations, adding amount of material through the cylinders, adding the additional materials in the cylinder or spheres. How insulations will be covered. The adding of how heat transfer takes place. Energy transfer takes place in energy. So in this heat transfer modes we have seen. Then the stage is you have a transient stage. Transient stage, Boyle chambers, lumped systems, semi-infinite stage and infinite stage. Important number is Biot number. Biot number less than 0.1, lumped system analysis. Same thing we have discussed in this modes. What is the reality of applications? You can see in the turbines, nozzles, in any engineering applications we can use. Then we have covered with convert the topics into the non-dimensional numbers and condensation. Condensation is the process by which vapor in the form is changed in the liquid water. It is opposite to evaporation. Condensation is crucial water cycles because it is responsible for formation of clouds. Film condensation occurs when the temperature of vertical, intermediate and wettable walls next to porous medium saturated with vapor walls below the saturation temperatures. Gravity-driven downward liquid flow and liquid-infilled vapor regions are due to capillary force. It's one of the example of film condensations. Drop-wise condensation is the condensed liquids collects in the form of counterless droplets of varying diameters on the condensation surface instead of forming and continuous films and dozens of wet in the soils and cooling surface. This is the examples of ice melting in the waters, the bubbles regions. Everything we'll see in the boiling modes and condensation modes we can see. Thank you so much. Listen to all participants and students. Thank you so much.